Good evening, my YouTube viewers. It is Crystal here. I'm just here this evening because I want to give you a code review. I'm still going over time series analysis and TensorFlow. We're going to be doing time series analysis with TensorFlow. And I found some code which I adapted for my own purposes. And that's what we're going to do. We've adapted it for my own purposes. And I'm going to go over the review with you. But we're going to be talking about a BILSTM and a GRU. So a BILSTM is a bidirectional LSTM layer, is an RNN layer that learns bidirectional long-term dependencies between time steps of time series or sequence data. These dependencies can be useful when you want the RNN to learn from the complete time series at each step. And I couldn't really find anything about the GRU, so I found something from Towards Data Science, where it says recurrent neural networks, that's RNNs, are designed to handle the complexity of sequence dependence in time series analysis. And then she gives you a tutorial where you're going to build a GRU and a BILSTM for a univariate time series predictive model. A gated recurrent unit GRU is a new generation of neural networks and is pretty similar to a long short-term memory, whereas the idea of bidirectional LSTMs is to aggregate input information in the past and future of a specific time step in LSTM models. And let's see when this was made. I'm not sure exactly when it was made. It was made in 2020. So in 2020, a GRU was new. And the thing is that, I'm taking these TensorFlow courses. And when I took the TensorFlow courses, I learned about LSTMs, but I didn't learn about BILSTM, and I didn't learn about GRUs. So there's a lot to know in TensorFlow. I've got a lot to learn, and I'll just have to keep on doing TensorFlow. And then one day I'll be good enough on TensorFlow where I will be able to make a course in Udemy. But until that time, I'll still have to keep on working with TensorFlow. So now that we've told you a little bit about GRUs and BILSTMs, which are part of a RNN, which is a recurrent neural network, we'll go ahead and go through the code review. So I did this code in Google Colab, which is a free online Jupyter notebook hosted by Google, and the code was inspired by this website right here. That's a GitHub account, I think. Well, this GitHub account with the code, but I had to modify the code for my own personal needs, so I didn't just use the code verbatim. And see, the thing is that I'm still learning myself, and since I'm still learning myself, quite often I have to look at other people's codes before I get proficient enough where I can do the code myself. So after we create the Jupyter notebook, we want to import the libraries. In this particular instance, I imported all the libraries at the top of the program, and that's what they want you to do, but that's not always what I do. I generally import the libraries as I need them, but I decided to go ahead and do it the way it's supposed to be done this particular instance. So we imported pandas as PD, which creates the data frame and does the data processing. We import NumPy as NP, which creates the NumPy arrays and calculates numerical numbers. Okay, we're going to import sklearns, min-max scalar, and standard scalar. We're going to use the standard scalar. No, we're going to use the min-max scalar, I think. And then that's where you're to scale the data, because you have to scale time series data. Whenever I was working on it, I worked on it with scaled data and unscaled data, and I think it worked better with scaled data, so I scaled it. We're going to import matplotlib.pyplot as PLT. That's going to visualize the data. We're going to import Seaborn as SNS. That's going to statistically visualize the data. We're going to import Tensorflow as TF. That's going to create your neural networks, your GRU, and your BILSTM. We're going to import Keras because the sequential model is in Keras. We're going to import sequential layers and callbacks with Keras, and we're also going to import layers, dense LSTM, dropout, GRU, bidirectional. And then when we want to see what version of TensorFlow we have version 2.12. It's important to know what version of TensorFlow you're working at, because TensorFlow has gone through a lot of modifications, and because it's gone through a lot of modifications, a lot of its code is deprecated. So now what we do is we set up a random seed, so we'll get the same result after each time running the code. So tf.random.setSeed is 42. Now we're going to read file. I used a GitHub, a CSV file that I got off GitHub, and this is global temperatures. And then, but I only wanted to use the first two columns of the global temperatures. I didn't want to use anything else. So df equals pd.readcsv, and then the link, the web address to the CSV file, df equals df.iloc, all of the columns, and all of the rows and columns 1, 0, and 1, and then you can see we've got df. So df is your date and your land average temperature. We check for null values, and we've actually got 12 null values in this data set. So we're going to fill NA. So we're going to fill the values with the value that they had before it was NA. And that's what we're going to do, rather than try to use medium or mean or mode. We're just going to use the last. So like if number 1 is a value and then number 2 is not a value, we're going to take number 1 and put the value of number 1 in number 2. So that's what we're going to do. We're going to fill all of the null values with the value that it had before it was null value. And so we did that, and so now we've got no null values. And then so now what we're going to do is we're going to date stamp the date, and we're going to make the date the index. And then so you've got your date as your index and your land average temperature as your univariate data. So we're going to visualize it. So this is a visualization from 1769 to a long time, over 200 years, maybe close to 240 years, 267 years perhaps. I think that's what they said it was, 267 years. And because it goes all the way to 2015. And you can see, even though it's a lot of data points, you can see that the temperature is even slowly decreasing, even though you've got all of those data points. So what we're going to do is we're going to resample it. So df year equals df land average temperature dot resample y dot mean. So we're going to resample it yearly and take the mean of the year, and then we're going to plot it. And then so when we plot this, you can see that the temperature it's very slowly but surely increasing. And so, and let's just look here. So the first date was 1750 and the last date was 2015. So that would be like 265 years, I think. You know. We check the shape of DF here, and it's 266 with one column. Now what we're going to do is we're going to split the data into training and validating sets. So train size equals int len DF here is 0.9. And then we have to use iloc. So train data equals DF here dot iloc. All of the rows up to train size, and test data equals df year dot iloc, the train size to the end of the data set. And then we check the train set and the test set, and so the train set is 239 rows and test set is 27 rows. And now what we're going to do is we're going to use sklearn's min-max scaler to scale the data. So we fit the data onto the trained data, and then we transform the trained data and the test data. And now what we're going to do is we're going to create a data set. So we're going to do a function that says create data set. So and it's going to accept x, and it's going to say look back equals 1. So xsyx equals 2 blank list for I in range len x minus look back. V equals x, I to I plus 1 look back. I plus look back. Xs dot append V, ys dot append x, I plus look back. Return np array xs np array ys. And then x train y train equals create data set train scaled 1. X test y test equals create data set test scaled 1. And then we get the shape. So X train is 238 rows by 1 column by 1. Y train is 238 rows by 1 column. X test is 26 rows by 1 column by 1. Y test is 26 rows by 1. And now we're going to create the models, and then we've got the 2 models created and 1 cell. And so we're going to create the GRU, and then we're going to create the BILSTM. So the GRU is a sequential model, and model add GRU, units equals units, return sequence equals true, input shape equals xtrain.shape1 and xtrain.shape2. Model add dropout 0.2. You're going to have a hidden layer. Model.add gr units equals units. Model.add dropout 0.2. Model.add dense units equals 1. And then we compile the model. The optimizer is Atom and the loss function is MSC. And then return the model. And so for model GRU equals create GRU 64 units. And now we're going to create the BILSTM model. We're going to have a function to do that. It's a sequential model. Model.add bidirectional LSTM units equals units, return sequence equals true, input shape equals xtrain.shape1, xtrain.shape2. You have a hidden layer of model.add bidirectional LSTM units equals units, model.add dense, compile model is model.compile, optimizer is Atom, and loss is MSC, and then you return the model. So I'll do that. And then, so you have model BILSTM equals create LSTM BILSTM 64. and then we're going to fit the model. So, and that's going to be a function as well, def fit model. Early stop equals char.callbacks. Early stopping monitor equals valve loss. Patience equals 10. History equals model.fit. X train, Y train. Epochs equals 100. Validation split equals 0.2. And then I don't think it really matters whether it's 0.2 or 0.1, but I'm going to make it 0.1. Batch size equals 16. Shuffle equals false. Callbacks equals early stop. And then you return history. Then you have history, GRU equals fit model, model GRU, and history by LSTM equals fit model by LSTM. So she had both of the models in the same cell. And then, so we run both of the models in the same cell, and so you can see that that's your MSE when it's standardized. So now what we're going to do is we're going to do model performance on history GRU, and you can see the model performance. You've got a very low MSE, and the reason why is because the data has been standardized. And then we have history dot by LSTM, and you can see there you've got a very low MSE as well. So now what we're going to do is we're going to predict on the data, and so we have to inverse the scaling because we previously did the scaling. And then so on Y test and Y train, and then def prediction, so you're going to make a function for the prediction. Prediction equals model.predict x test. Prediction equals scalar inverse transform prediction. So you have to reverse the scaling, and then you return prediction, and it says prediction GRU equals prediction model GRU. Prediction by LSTM equals prediction model LSTM. And now we're going to plot the test data versus the prediction. So we're going to plot all that, and then we're going to calculate the MAE and the RMSE. So this is what we've got. So we've got for the GRU, we'll say RMSE is 0.6690. For the bidirectional LSTM, the RMSE is 0.6364. So that's what your error is when the data has been standardized. If it's not been standardized, it'll be higher. And then so this is what your GRU is, and you can see that the prediction temperature is lower than the actual temperature for the GRU, and also for the bidirectional LSTM, the predicted values are less than the actual values. So what that means is all of these people who are working on climate change, if they're using this model as a GRU or by LSTM, then the temperatures that they are predicting are going to be less than the actual temperatures. And now what we're going to do is we're going to visualize the predictions. So year new equals NP arrange 0 to len DF. And then year pred equals NP arrange 240 to len DF year. And Y equals NP dot array DF year. PLT year new Y. And then what that does is that plots the values all from 0 all the way to 267. And then PLT plot year pred prediction GRU REFL, and that plots the ampere. And so you can see that the predictions are actually less than the actual levels. And I used this code I had to modify the code, but I used the code by this woman as the basis, even though I modified it. And so now what we do is we check the visualization for bilateral LSTM, and you can see that the predictions are less than the actual values. So what that indicates is these individuals who are studying climate change and who are using machine learning or time series forecasting to study the climate change, if they're using by LSTM or GRU, then the temperatures that they come up with are likely going to be less than the actual temperatures. And there's other things you can do, because I've made other videos on time series forecasting with stats models. But I think Tensorflow is the most popular library, and people are trying to use Tensorflow because Tensorflows are your neural networks, and your neural networks tend to, well, it's supposed to work better than other methodologies, but sometimes I've found that to be the case, but sometimes I haven't found that to be the case. So what you have to do is you have to go through every data set, and then you have to check it with a number of models. And then when you've checked it with a number of models, then you can decide which model works best. But in this particular video, we're using TensorFlow because that's what I'm trying to study. I'm trying to study TensorFlow, and I'm trying to build a portfolio of TensorFlows. And then at some point, whenever I feel that I know enough about TensorFlow, I'll probably do a course on Udemy of TensorFlow. So that's it for this video. We've covered the code. We've covered some bits that were in this program that this woman wrote, but some bits I put in there because I put this code in here. This code right here was inspired by Chris Nate, but I had to modify it. And all of the code that I used in this program, even if it was inspired by somebody else, I still had to modify it to meet my needs. So that's basically what I did. So I'm going to go ahead and conclude this video, and I would like to thank all of my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. If you want to be notified whenever I make a new video, then please tap on the bell button whenever I make a new video. Please tap onto the bell button next to the subscribe button. And thank you so much for watching this video. I look forward to making more videos for you in the future.